Causes of Venus's atmospheric superrotation. Venus has atmospheric motion that orbits rapidly in an east-west direction. This video examines Venus's atmosphere, which is driven by the solar wind. Charged particles in the solar wind are fast, and the faster the speed, the stronger the Lorentz force becomes. Due to the mechanism of pinch effect, the charged particles moving in parallel attract each other and converge at the center of the flow. When hydrogen ions recombine with electrons, hydrogen atom loses Coulomb forces, but it continues the movement in the same direction due to inertia. Because these interactions will be repeated, the solar wind spreads out in a disk shape centered on the ecliptic plane. When that solar wind collides with a planet, it causes atmospheric movement that orbits the planet in an east-west direction. Why solar system forms a disk shape? Solar wind has a characteristic to converge toward the center of flow. The amount of solar wind emitted from the Sun is 1 million tons per second, and its main constituent is proton H+. Each proton has a speed of from 300 to 900 km per second. Furthermore, the solar wind rotates counterclockwise on the surface of the Sun at 1.89 km by sec due to the Sun's rotation. When the solar wind collides head-on Venus, it drives Venus's atmosphere clockwise direction by the gear's meshed mechanism. Emitted solar wind is a plasma state, where ionization and recombination take place repeatedly. In the ionized state, moving charged particles function as electric currents and magnetic interactions will occur. Since mass of an electron is 1 by 1836 of a hydrogen ion, so the movement of hydrogen ion is hardly changed by behavior of electron. Moving hydrogen ions are affected by Lorentz force. When two hydrogen ions move in parallel, they attract mutually as parallel electric currents. After H+ recombines with an electron E, hydrogen ion becomes neutral and loses the Coulomb force, but the recombined hydrogen atom continue the movement of the former ionic state. The effect of Lorentz force will be emphasized by inertia of the movement. Therefore, the particles of solar wind emitted from the Sun has a mechanism that charged particles converge towards center of the flow. So, the solar wind spreads out in a disk shape centered on the ecliptic plane. So, the amount of solar wind that collides with the planet is not decreases compared to the case where it is released spherically symmetric. Where did come from atmosphere of Venus? Formation of protoplanetary disks. The planets in the solar system were born from a massive disk of dust rotating counterclockwise proto-solar nebula. Fig. 1 shows a new model of formation of solar system where solid CO2 and iced H20 had included in the rocky planets such as Venus before the Sun emit the solar wind. Formation of the solar system. The solar planets orbit around the Sun. Range of heliopause is the area where solar wind reach. The size is 100 to 120 astronomical units. The distance from the Sun to Neptune is 4.5 billion kilometers, 30 astronomical units. Charged particles of solar wind are emitted with very high speed, and parallel running charged particles are magnetically coupled, same as parallel electric currents. Table point 1 shows the orbital inclinations of planets. Those orbitals are slightly offset from the ecliptic plane. CO2 and H2O had included a solid state during the formation of the planet. It is difficult to include CO2 and H2O in Earth or Venus during solar wind blows through. Therefore, CO2 and H2O in the rocky planets were included as solid state before the Sun underwent nuclear fusion reactions. Why most of planets rotate counterclockwise direction? Rotation periods of planets in the solar system except Venus. Fig. 2 shows the relationship between rotational period and mass of planets in the solar system excluding Venus. The planet's rotation period tends to shorten as the planet's mass increases. This relation suggests that as a planet grows, its rotation speed increases. The reason large planets have shorter rotation periods indicates that the falling materials orbited the planet's orbit before fell down. When the rotating matter falls into the planet, the angular kinetic energy of the falling object will be added to the planet, causing the planet's rotation speed to increase. However, Venus currently rotates clockwise direction. It will be estimated that primitive state of Venus had rotated counterclockwise direction. Why Venus rotates clockwise direction, unlike other planets in the solar system? Current Venus's rotation is very slow, and direction of the rotation is clockwise. There is the explanation that Venus rotates clockwise because it collided with other planets, and its rotation was changed from counterclockwise direction to clockwise. However, Venus's orbital eccentricity is E equals 0.0068, making it the closest planet to a perfect circle in the solar system. The collisions with other celestial bodies is hard to reverse of its rotational direction under the condition of keeping nearly circular orbit. The clockwise atmospheric superrotation of Venus is possible to change Venus's rotation from counterclockwise to clockwise direction. Why Venus's atmosphere flows at high speed? What is superrotation of Venus? There is high-speed flow of atmosphere called the superrotation in Venus. The wind rotate from east to west in an around cycle of 4 days. Fig. 3 shows the wind from east to west on Venus's atmosphere at day hemisphere and night hemispheres. This atmospheric flow on Venus has speed of 100 meters per second at an altitude of 60 kilometers, but it slows down at low altitude. It reaches to 0.3 or 1.0 meters per second on the surface. Venus's surface is a supercritical state of CO2, of which atmospheric pressure is 92 atmospheres, temperature is 460 degrees Celsius, which has properties of intermediate between gas and liquid. If the movement of Venus's atmosphere is caused by the temperature difference between day and night, strong winds will flow at the boundary between day and night. However, the movement of atmosphere is not fast at boundary as shown in Fig. 3. Y rotation of Venus itself is clockwise direction. Current Venus rotates clockwise with a period of 243 days. Here, solar wind contains counterclockwise rotational component of 1.89 kilometers sec due to the sun's rotation. Venus's atmosphere was driven by the solar wind. The clockwise rotation of Venus's atmosphere is caused by rotational component of solar wind through a gear mechanism. Moreover, the superrotation is possible to change the rotation of Venus over many years. Magnetic coupling among running charged particles. Lorentz force among high-speed charged particles. The force on a charged particle Q with velocity v in an electric field E together with a magnetic field B is expressed by Eq.1. The first term of Eq.1 is the Coulomb force, which depends on the distance between charged particles. The second term is the Lorentz force by a magnetism of B. Moving charged particle QV equals J possesses B. Ampere's law is expressed by rotation B equals mu0 J. Here, the rotation has X components perpendicular to YZ plane, Y components perpendicular to ZX plane, and Z components perpendicular to XY plane. If J is perpendicular to B, the second term of Lorentz force has the effect. Definition of vector potential A. The magnetic field B acting on the current J is represented by the vector potential A defined by Eq.2, and the energy density for J is given as Eq.3. Operation of rotation on Eq2 gives the Lorentz force of Eq.4. Rotation equals minus exterior vector product of J and B. Here, negative symbols means that currents in the same direction attract each other. Substitute Eq.2 into rotation B equals mu0 J, we get rotation A equals mu0 J. From formula of vector analysis of rotation A equals gradient divergence A minus Laplacian A, and setting divergence A equals 0, Eq.5 is obtained, and the vector potential A is obtained by Eq.6. The relationship between J and A resembles the relationship potential V and charge density ρ. These potential becomes weaker as the distance increases. Kinetic energy of solar wind accumulated on Venus. The effects of solar wind on Venus's atmosphere. Amount of H+ of solar wind that collide with Venus can be estimated by using amount of H+ emitted from the Sun. The amount is MP equals the 9th power of 10 kg by sec. Assuming the charged particles from the solar wind concentrate around the center of a disk shape along the ecliptic, we can estimate the mass of the solar wind that collide with Venus. Setting the distance from the Sun to Venus's orbital orbit is r equals 1.08 times the 8th power of 10 km, and the thickness of the solar wind disk is assumed as Sun's diameter, d equals 1.392 times the 6th power of 10 km. The cylindrical surface area of Venus's orbital is S surface equals 1.5 the 14th power of 10 squared km. The total mass of solar wind from the Sun is MP equals the 9th power of 10 kg by sec. The cross-sectional area of Venus S Venus equals 1.15 times the 5th power of 10 squared km. Assuming that particles are uniformly distributed in the disk, the ration gamma equals S Venus by surface is obtained by gamma equals 0.76 times the minus 6th power of 10. There, Venus will collide with 0.76 times the minus 6th power of 10 times the 9th power of 10 kg by sec. When that accumulates over 4.5 billion years t equals 1.42 times the 15th power of 10 seconds, it becomes 1.09 times the 18th power of 10 kg. Verification on the theory that the solar wind changed Venus's rotation. Setting the velocity of particle of solar wind particles is v equals 500 km by sec. The kinetic energy K solar wind on Venus exerted by the solar wind on Venus is given equation 14. K solar wind on Venus equals 1 divided by 2 times m times c squared versus equals 1.36 times the 29th power of 10. On the other hand, the moment of inertia I3 of a uniform sphere is given by I3 equals 2 divided by 5 times m times r squared, and using Venus's mass is 4.87 times the 24th power of ton kilogram and Venus's radius r equals 6.052 times the 6th power of 10 meter. the moment of inertia is I3 equals 2 divided by 5 times m times squared r equals 7.13 times the 37th power of 10 squared kilogram squared meter. Assuming the early rotation of Venus was 1 rotation per 1 day like rotation of Earth, with a rotational angular velocity is given by omega equals 7.26 times minus 5th power of 10 radians by sec, the total rotational kinetic energy of that rotation is given by equation 15. K total for life equals 1 divided by 2 times L times squared omega equals 1.87 times the 29th power of 10 compared to the energy of Venus's rotation. The kinetic energy that the solar wind gave Venus is equivalent to 0.732 times. This result supports the possibility that Venus's rotation was changed by the solar wind. Conclusion: Venus rotates extremely slowly, but its atmosphere orbits Venus at an extremely fast velocity. This phenomenon has remained unexplained up to now. The author proposed the following mechanism. The reason for the fast atmosphere orbiting Venus is due to the nature of plasma, where fast charged particles concentrates towards center of the flow. The movement of high-speed charged particles in solar wind has characteristics to converge toward to center of the flow. As the velocity of charged particles increases, the Lorentz force increases. When these hydrogen ions recombine with electrons, the hydrogen atoms lose the repulsive reaction of Coulomb force, but the same motion continues due to the inertia. When such phenomena are repeated, the solar wind converges at the center of the flow rather than a sphere and spreads out in a disk. Those effects influence planetary formation and atmospheric movement. Using this disk-shaped model of the solar wind, the author estimated the accumulated kinetic energy of the solar wind over 4.5 billion years. The obtained results comparable to the momentum assumed that Venus rotates once per day. Venus's rotation. This will be one of the evidence that is explained that the superrotation of Venus is caused by the solar wind. Thank you for your attention.